Hi everyone, for today's lesson we are going to learn about corresponding parts of congruent triangles are congruent. This is a new conclusion that we can draw after we have proven triangles are congruent. So, our I can statement for today is for you to be able to say, I can prove that other corresponding parts. So we're talking about after you prove that triangles are congruent, you are going to be able to prove that other corresponding parts, which remember, corresponding parts are matching parts. So I can prove that other corresponding parts of triangles are also congruent if I know that the two triangles are congruent. So what's going to happen is you are going to know or prove that two triangles are congruent. You're going to prove that just like normal. We know that we can use side, 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 angle, side, angle, side, angle, 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 side, and RHL. So these are all of the ways that we have learned how to prove triangles are congruent. And we're now going to take our proofs to the next level. So now that we know that triangles are congruent, what else can we say? And that's where corresponding parts of congruent triangles are congruent comes in. The shorthand for that is CPCTC. CPCTC, that's our shortcut. So for today's lesson, as you guys have already seen, you're going to want to have some colors. You're also going to want to have a glue stick, something to write with, and you're going to need your cutouts for Unit 4, Day 8, and Day 9. So please go ahead and have out these materials for today's lesson. So I would like you guys to please go ahead and take out the CPCTC. That is a mouthful. That's a really tough thing to say. CPCTC. Practice that while I get out my glue stick and I glue this into my notebook. CPCTC. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. CPCTC. So remember, corresponding means matching. So we are talking about matching parts. So what we'll have is we'll prove that two triangles are congruent. That's our first step. You prove that two triangles are congruent. And then from there, you will be able to state that corresponding parts, whatever the proof is asking you to prove, you'll have to state that corresponding parts are congruent. And the reason is simply CPCTC, because matching parts of congruent triangles are also congruent. And that goes back to the very beginning of this unit where we showed that all 6 pieces of information needed to be congruent in order for two shapes or figures to be congruent. And then we whittled it down into you only really need to have 3 pieces of information. Side, 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 angle, 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 side, and RHL. So now we're kind of going back to the very beginning of this unit by saying, well, now that we know that these triangles are congruent, we can also make other statements and claims as well. And the reason why we want to do that is if you have corresponding parts that are congruent, like let's say that you show that in 2 triangles, so I'm just going to draw 2 triangles really quick. And we're told that these 2 triangles are congruent. Just forgive this awful drawing now that I'm looking at it. Just forgive it. Just pretend as if it looks like 2 congruent triangles. Let's pretend that. And you were told that these 2 triangles are congruent. Let's say that we know that they're congruent by angle, side, angle. And you prove that these 2 triangles are congruent by angle, side, angle. And now we can say, all right, cool. We've proven that these triangles are congruent by angle, side, angle. Now what? Well, now you might be asked to say, well, show that these 2 sides are congruent. So we'll show that these two sides are congruent, and that makes sense. These two sides would be congruent because corresponding parts of congruent triangles are congruent. And then what's going to happen after that is because these two segments are congruent, we can say that a certain point is a midpoint. And that's what the second half of this lesson is going to be about when we finally get into proofs. So there's a reason for everything. The first thing we do is we're going to prove triangles congruent. The second thing we're going to prove is whatever side length they're wanting us to prove. We'll have to say that those corresponding parts are congruent because of CPCTC. And then later on in this lesson, once we finally get to the examples, we're going to be able to say since these two side lengths are congruent, or since these two angles are congruent, we can now draw a further conclusion about midpoints or angle bisectors, etc. All right, let's go ahead and do an example because I think that would really help us out. So remember, all we're doing is proving that the triangles are congruent using the exact same steps that we've already done. But what's going to be a little bit different this time is that I am not giving you the triangle order in order for our proof. Instead, what we're going to do is I'm going to give you information and then I'm going to ask you to prove that other side lengths are congruent. So there's no triangle information that's given to you. You will have to come up with that statement on your own based on corresponding parts. So let's go ahead and dive in and mark up our picture based on what's given to us. So I have AB is congruent to DE. So I'm going to mark up that AB is congruent to DE. Cool. I'm also told that angle ABC, so here's ABC, this angle right here, is congruent to angle DEC. So here's DEC. And now I need one more piece of information in order to prove triangles are congruent. And what I see in this picture is I see vertical angles. So because I have vertical angles, I am going to name these angles. So based on what I see here, I'm going to say that angle ACB has to be congruent to this angle. And this angle is going to be angle, well, it looks like A doesn't have an arc mark and neither does D, so it has to go DCE. So these two are congruent because we know that vertical angles are congruent. Nice. So now we have to make a decision. How can we prove these triangles are congruent to each other? So I see two triangles here. I see triangle ABC and I see triangle DCE. I'm sorry, DEC. And what I'm going to do is I'm going to say that because I have three pieces of information and I also see angle, angle, side, that I can prove triangles congruent by angle, angle, side. So this is all stuff that we've already talked about before, but the thing that's missing is our triangle congruent statement. Notice we're trying to prove that side lengths are congruent, and I don't have a triangle to refer to. So, or a triangle statement to refer to. So we have to come up with our own triangle statement. So I'm going to say that somehow I'm going to prove that triangle ABC is congruent to triangle, well, A corresponds with D, B corresponds with E, and C corresponds with itself. There's my triangle statement. So I'm going to use vertical angles to state that I have two angles that are congruent. I see angle, angle, side, so that's where this piece came from. I'm going to say that these two triangles, triangle ABC and triangle DEC, are congruent to each other. And then from there, I can finally say, now that I have triangles that are congruent, once you prove those triangles are congruent, we can say or state that corresponding parts are also congruent. So our corresponding parts, being DC and BC, must be congruent by CPCTC. Corresponding parts of congruent triangles are congruent. All right, let's go ahead and write down what is given to us. So I have notice the given is not split, so I'm just going to write this as given. And next I have angle ACB is congruent to angle, and it says ECD. Why does that say that? So I have ACB I don't know why this says this order. This is a mistake. It should be, because we talked about this, A has to match with D. So that's the only thing that makes sense. And then I have E matching with B. So I'm going to go back to this order right here. I am so sorry, guys. This is the wrong order. We're going to change this to DCE. ACB is congruent to angle DCE. And the reason why is that if two angles are vertical angles, then they are congruent. And that is our if-then statement for triangles. And if you need to reference that, go to your wording for Unit 4 proofs and go down to where it says theorems. This is the vertical angle theorem. If two angles are vertical angles, then they are congruent. Then we have triangle ABC is congruent to triangle DEC. So what I have up here back in the beginning is I have a side that's identified, and I have an angle that's given to me, and now I have my remaining angle identified. So since I have all three pieces of information identified, I can now say that triangle ABC is congruent to triangle DEC by angle, angle, side. So now that I have proven triangles are congruent, I'm done with step one. My last step is what I'm trying to prove here is that DC has to be congruent to AC. So I am able to say that DC is congruent to AC simply because these two triangles are congruent. And we know that corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. CPCTC. In some homework assignments and in other things, you might see the if-then statement for CPCTC. The if-then statement is if triangles are congruent, then all of their corresponding parts are congruent. Or if all of the corresponding parts are congruent in a triangle, then the triangles have to be congruent. This is your CPCTC area for congruent triangles. For short, we're just going to work with CPCTC. And that's what a proof looks like. It's the same exact proof that we did before, only a couple of extra steps are added. The first extra step is that we're going to have to come up with our own triangle congruent statement. Our last step is that we're going to have to say that a part, whatever you're trying to prove, is congruent. And that third step, depending on how things go, they might ask you to prove that maybe C is the midpoint of DB, for example. And if you needed to prove that something is a midpoint, then you would somewhere need to show that DC is congruent to BC. Since that's not what's going on in this problem and it doesn't really work out for this particular proof, we are not going to do that, but that is where we're heading to. That is the end of today's lesson. If you have any questions over CPCTC, please feel free to email me. Otherwise, I hope you have a wonderful day.